Hello friends, the topic of today's video is AVL tree. In my last video, that is limitation of binary search tree, where I have discussed what is the problem with binary search tree and how that can be overcome through AVL tree. So what is AVL tree? AVL tree is height balanced binary search tree. Here the balance factor for every node is calculated and allow balance factor is -1, 0 and 1. Now how balance factor is calculated? Balance factor for every node is calculated through height of left subtree minus height of right subtree. That is how the balance factor is calculated. And the allow balance factor is either it can be -1, 0 or 1. Not it should not be greater than 1 or it should not be less than -1. That is 2 is not allowed, -2 is also not allowed. So that is how balance factor, that is height of left subtree minus height of right subtree should be less than equal to 1. So balance factor should not be greater than 1 and less than -1. So here there are four types of variation having same values. So let us draw the binary search tree and then we'll see if there is any problem or not. So in binary search tree we cannot control the height of the tree, but in AVL tree we can control the height of the tree. So that is the main advantage of AVL tree. So what is the advantage in controlling the height of the tree? The advantage is in searching. So if the height of the tree is or if the tree is balanced, then searching is very easy. Where we can see in binary search tree, searching is very tedious because we cannot control the height of the trees, but in AVL tree we can control the height of the tree through balance factor. So let us draw the one by one. So first is 15, 10 and 9. So let us draw the binary search tree. It will be 15 and then 10 will come on left hand side and then 9 will also come on left hand side. Now again uh, balance factor is calculated for every node, so here it will be 0. Now what is balance factor is calculated to height of left subtree minus height of right subtree. Here there is nothing. Then here height of left subtree is 1 minus 0 is 1. Then height of the balance factor for 15 is height of left subtree minus height of right subtree. So here there is no right subtree, so it will be 2 minus 0. So it will be 2. Now here this node is balanced, this node is balanced, but this node is not balanced. So here what is needed? We have to certain rotation is required. So this type of this imbalance factor is nothing but LL. So if you see, there is imbalance is on left hand side. So this is first L and this is second L. Now there can be any number of nodes in binary search tree. So how much we can consider, or how many nodes we have to consider for balancing? So in AVL tree we have to consider only 3 nodes. You have to remember, you have to consider only 3 nodes which cause imbalance. So here you can see there is imbalance on left and it is again to left. So what we have to do? We have to rotate this tree like this. On one rotation is required on right hand side. So this is LL. So this is LL rotation. So what happens in LL rotation? If you look here, 10, 9 and 15. So in LL rotation we have to rotate the tree to the right by one move. So again if you see the balance factor, now it will be 0, 0. 1 minus 1 is 0. The tree is balanced. So this is LL rotation. Okay, so I do hope you understand LL rotation. Now next, 1 minute. So next is 9, 10 and 15. So let us draw the binary search tree for 9. So 9 will be root node, 10 is on right hand side and then 15 is again greater than 10. So it will be, so if you again calculate the balance factor, here it is 0, it is -1 minus 0. Sorry, 0 minus 1, it is -1. 0 minus 2 is -2. Again -2 is not allowed. This node is imbalanced. So if you look, there is imbalance on right hand side. So this is first right, this is second right. So this type of rotation is RR rotation. So what we have to do in this case, we have to rotate the node to left. So we have to keep this node as it is and this node will be here. So we have to, in RR we have to rotate the tree. So it will be 10, again 9 and then 15. So if you again calculated balance factor, it will be 0 0, okay, and then 1 minus 1 is 0. So this, now the tree is balanced. So this type of rotation is RR rotation. Now next type is, next is 15, 10 and 9. So again I will draw the binary search tree. 15, left hand side 9 and then 10. So if you look here, 15, 9 and 10. So if you calculate the balance factor, it is 0. Again it will be 0 minus 1 is minus 1, and then so we have to calculate the height from the left part. So again on left part it is 2. So 2 minus 0 is 0. 2 minus 0 is 2. So again the 15 is imbalance. So if you now here if you find there is one left and right. So tree is imbalance on one left, one right. So this type, this is called as LR rotation. So what happens in LR rotation? We have to move this node, that is 9 to the left, and 9 to the left, and 15 will come here. So I will do first rotation L. So it will be 10 will come here, 9 will come here, and 15 will be here. So this is L, and then there is R. So in okay, now if you look here again, this is LL rotation. So this is L and L. So what happens in LL? We have to move the tree to right. Okay, we have move the node to right. So it will be 10, then 9 and then 15. So we have to move this node to 9. Move this node to right. So again this tree is now balanced 0 0. 1 minus 1 is 0. So this type of rotation is called as LR rotation. Now last rotation is RL rotation. So let us see what is R and L. So 9, last one, this one 9, 15 and 10. So if you calculate the balance factor here, it will be 0. So it will be 1 minus 0 is 1, and then again from right hand side if you look, 0 minus 2 is minus 2. We have to check the height from the right side. So it is 1 and 2. So that's why 0 minus 2 is minus 2. Again this is imbalance. Okay. So we have to create the balance here. So yeah, I will tell you one tip, that which will be the root node in case of LL and this type of an RL rotation. So if you look here, this is RL rotation. The reason is here there is R, this is R and this is L. So this is called as RL rotation. So in case of LR and RL rotation, there is one tip from my side, that root node will be always the median. So what is, how to calculate median? Here there are 9, 10 and 15. So which is the median value? Median value is 10. So always root node will be median. Remember this thing. It will be useful in all the problem. So but here I will solve step by step. So first of all we have to move this this node to the right. Okay, this node. So this node. So it will be 10 and then 15 and then 9. Now this is again RR, first R, second R. Now what happens in RR? We have to move the tree, move this root node to right, left. So it will be like this: 10, then 9 and then 15. Now the tree is balanced. So this type of rotation is called as RR rotation. So there are four. So we have gone through 4 types of rotation. Which are those? The rotation are LL, RR, RL and LR. So these are the rotation. So in case of LL rotation, we have to move the root node to the right. Move to the right. In case of RR, we have to move the root node to left. Then in case of RL, we have to move the root node to right hand side and then again move the tree to right. So in case of remember this thing, in case of RL and LR, the root node is always median value. So that's it for this AVL tree. I do hope you understand this AVL tree and rotation LL, RR, RL and LR. So thank you for watching this video. Please subscribe to this channel.